Everyone, my name is Wante Erisa. I'm your online math teacher on YouTube. So many of you have been telling me, who is this guy behind all these videos? It is me. I teach mathematics. I'm here at the Oklahoma State University in the United States doing a master's in mathematics. But I do feel for my people in Uganda, especially the children who are disadvantaged, who cannot make a private arrangement with a tutor. So I post these videos. If you have some data like 50 MBs or you can access Wi-Fi, it is always good for you to go online and learn something. So today I wanted to post my videos so you can try to really get to know the guy behind everything you are learning. So it is me, but when I'm recording, I always take out the video, because if I do include my video in the recording, the file size is going to be so heavy for you, and accessing such data, no, it might rip out your pocket. So I'll always take out my video, but once in a while I will turn on my video so you can try to see who is this guy behind everything. It is me. Anyway, let me hope you guys are enjoying. Thank you so much. Today I decided to use small functions of this app, and I've done some typing and I'm really impressed with that. So we have been talking about expectation and the variance of a discrete random variable. Today we want to talk about the cumulative distribution function. Okay, so how do we pick up this picture of the cumulative distribution function? We begin with the probability distribution and then proceed to the cumulative. Okay, but to construct it, we apply the knowledge of cumulative frequencies, which you have covered in descriptive statistics. How do we get cumulative frequencies? We keep summing frequencies up to the last one, okay? And then the values we obtain are called the cumulative frequencies. So, in the same way, in a probability distribution, the probabilities up to a certain value are summed to give a cumulative probability. The cumulative probability function is written as a capital F of X. Now, let's consider the following probability distribution. Okay, let's look at this probability distribution. We have the variable, the values of the variable, and the probabilities. So we have for 1 it is 0.05, for 2 it is 0.4, for 3 it is 0.3, for 4 it is 0.15, and then for 5 it is 0.1. So let me put this in the table form. Now, what we call the cumulative distribution function, okay? A capital F of X is the probability at X is less or equal to a particular value of X. For example, if we want F of 1, then this is the probability that X is less or equal to 1. Now, when you check our table, the X values, these values given to us, the values of the variable, okay? The lowest value is 1, so there is no single value which is less than 1, and therefore, F of 1 is just the probability of X is equal to 1, and that is 0.05, okay? So, what about F of 2? This is the probability that X is less or equal to 2, okay? And the probability of X is less or equal to 2, there are two. We have probability of X is equal to 1, and then probability of X is equal to 2. So you get 0.05 and add on 0.4. What do we get? Let's see on the next page. F of 2 will be 0.45. So F of 3, this will be the probability of x less or equal to 3. Now, looking at our table, we have three values, that is 1, 2, 3. Okay, from 1 up to 3, this will be equal to probability of x is equal to 1 plus probability of x is equal to 2, then plus probability of x equals to 3. So when you check this part here, this is what we have just looked at f of 2. So what we can do, we can start this is f of 2 plus the probability of x is equal to 3. X is equal to 3. Okay, so I'm really going through the lengthy procedure to explain this to you so you understand. So we got f of 2 as 0.45, and then the probability of x is equal to 3. Check in our table, it is 0.3, and therefore the answer is 0.75. So what about f of 4? As a student, you should now be trying out because you've got the idea. F of 4 still done the same way. F of 4 is the probability that x is less or equal to 4. Okay, so I will say probability of x is equal to 1 plus probability of x is equal to 2 plus probability of x is equal to 3 plus probability of x is equal to 4. So I can write this as f of 3 plus the probability that x is equal to 4, because f of 4 will cover the whole of this part. Okay, and then the probability of x is equal to 4, but this is f of 3. Okay, so what do we get? F of 3 is 0.75 plus f of 4, which is 0.15. Therefore, what's f of 4? F of 4 is 0.90. Then f of 5 will be the probability that x is less or equal to 5. That is x is equal to 1 plus x is equal to 2 plus x is equal to 3 plus x is equal to 4, which is f of 4, then plus the probability of x is equal to 5. Okay, this is 0.90 plus 0.2. Sorry for that interruption. Someone was trying to get hold of me, but f of 5 is now equal to 0. No, it is now 1. There is something worth noting about f of 5. 5 is the last value x is taking. And we said when we sum all probabilities for all the x values involved, it is equal to 1. That's why f of 5 is equal to 1. It is a summation of probabilities from, in this case, from x is equal to 1 up to x is equal to 5. Okay, so you can note that f of 5 give the total probability. Okay, f of 5 will give the total probability. Generally, f of the last value of x will always be 1. So from this cumulative, we can construct the probability distribution function using the probabilities we have. Okay, now using the probabilities and the f values we have generated, let's construct the cumulative distribution function. So we have the x values and then capital F of x. Okay, x is 1, 2, 3, 4, I think up to 5. This was 0.05. Then this is 0.45. Then this is 0.75. Then we have 0.9, and lastly 1. So this table, okay, or this function that we have constructed is what we call the cumulative distribution function. Cumulative distribution function will always be given by a capital F of x. Okay, so we have the cumulative distribution function, and if you are told to plot the cumulative distribution against the x values, this is what you end up with. Okay, on the vertical axis, we plot the cumulative probabilities, and on the horizontal axis, the x values. So In this case, we have the first value is 1, then 2, then 3, then 4, then we have a 5. Okay, so this is 1, 2, 3, we have a 4, this is a 5, there is a 4 somewhere here, but I can't write because of the nature of the app I'm using. So that is it. Now we put here the other values. Maybe this is 0.1, but that's big. 0.2, 0.3, 0.4, 0.5. Let me change the scale. This is 0.2, 0.4, 0.6, 0.8, and then 1. Okay, so the value 1 has cumulative 0.05. So 0.05, if this is 0.1, then 0.05 is halfway, which is somewhere here. Okay, so this is what we do from 1 up to 2. Okay, we draw a line, a horizontal line, and then we dot here, but this is not so. Then from 2, f of 2 is 0.45, so 0.45 is gonna be in the middle here. Okay, this is 0.5, so 45 is somewhere here. So we can try to draw. Let me plot somewhere here. I have a point, and then here I also have a point. So I draw a horizontal line parallel to the horizontal axis. Okay, and then we dot here. These are like going up the stairs, so it will always appear something like that. Okay, so we have plotted so far. Then from 2 to 3, okay, we have f of 3, which is 0.75. So from 3 to 4 we have a step 0.75. This is 0.7. Somewhere here we have 0.7, then 75 in the middle. I'm trying to estimate. Okay, so this is about 0.75 here, and then this other point is right here. Okay, so you connect the two with a horizontal line. Okay, this is a continuous line, not a broken line. Then joining this, you will have this point and then this other point. Okay, then from 4 to 5 it is gonna be 0.9. So this is 0.9 somewhere here, 0.9. Okay, 0.9. Okay, hello, 0.9. 0.9, and then from 5 on it remains 1. So this is 5 on, it's gonna be 1. So that's the plot of a cumulative distribution function. It will always look like that. So that is it. On this axis we have the x's, and then this axis we have f of x's. So we have plotted the cumulative distribution function for this particular type of equation, but that's how it is going to look like. You know, it's going to be in steps, like climbing up the stairs. Okay, so let's look at some other example. Look at this example. For a discrete unknown variable x, the cumulative distribution function is given by, so this has been given to us as a formula. You know, the cumulative can also be given to you as a formula. So it is f of x is equal to x squared over 9 for the 3 stated x values 1, 2, and 3. So they want f of 2. F of 2 is direct substitution. There is nothing here. Okay, f of 2 is 2 squared over 9, which is 4 over 9. Solved that one, there is no need of wasting time. Then probability of x equals to 2. Okay, we know that f of 2 is a cumulative of probability of x is equal to 1 and probability of x is equal to 2. This is probability of x is equal to 1 plus probability of x equals to 2. Okay, and it gives us f of 2. Now, if we know the probability of x is equal to 2, if we know the probability of x is equal to 1, which is always direct substitution. Normally in the cumulative, the first value, when you substitute in the formula, that will be the exact probability of that value. So for x is equal to 1, it will be the same as f of 1. Now, let's go on the next page and do this right. Okay, we know f of 2 is the probability of x is equal to 2 plus the probability of x is equal to 1, okay? And we got this as 4 over 9 is equal to the probability of x is equal to 2. The probability of x is equal to 1, since 1 is the starting value, it will be f of 1 directly, okay? So probability of x equals to 2 will be 4 over 9 minus 1 over 9, which is 3 out of 9, okay? Then we need to write out the probability distribution, okay? So if we are to write out the probability distribution, we shall need the f of 3. F of 3 will be in this case, it is going to be 3 over 9 squared, which is 9 over 9, and this is a 1. Normally, f of the last limit will always be 1. So probability of x is equal to 3, okay, will be f of 3 minus f of 2. This is 1 minus 4 over 9, which is 5 out of 9. So if you try the probability distribution, then you have here x's, and the probability of x is equal to, okay, so what are the x values? We have 1, 2, and 3. For 1, which is 1 out of 9, okay. For 2, we are getting this as 3 over 9, and then this is 5 out of 9. So that's the probability distribution function, okay. So from there, they want us to find the expectation of 2x minus 3. If you are to get the expectation of 2x minus 3, then we have to remember what we have so far discussed. The expectation of 2x minus 3 is twice the expectation of x minus 3. So what we need basically here is the expectation of x. What is the expectation of x? We get x's and multiply by the probabilities. This is 1 over 9 plus 6 out of 9 plus 15 over 9. Okay, what do you get? 15 plus 6 is 21, so this is 22 out of 9. So the expectation of 2x minus 3 is 2 times 22 over 9, then minus 3, okay? So what do we get? 44 minus 27 out of 9. That is the expectation of 2x minus 3. You'll end up with the 17 out of 9, which is about 1.8 recurring. 1.8 recurring at 17 out of 9. So that is it, ladies and gentlemen. Try to check my answers with a calculator, since most of the time I always rely on mental work. All right, let's look at this example. It is a bit lengthy, but I believe we can do it. So we have been given the cumulative probabilities for x given the table, okay? The values are from 0 up to 12. That's why they are really many. So the question is very simple, but you got to really understand what you are doing. Use the table to find probability of x less or equal to 8. So that's simple. The probability of x less or equal to 8 is the same as f of 8, because for f of 8, we sum the probabilities of x values from the first up to 8, okay? Up to and including 8. So this is going to be, look for 8, that is 0.9900. We are done with that. Very simple. Okay. Then the next part, they want the probability of x equals to 5. Okay. Probability of x is equal to 5. You know, f of 5, you sum from 0 up to 5. Okay. So if you want the probability of x is equal to 5, you get f of 5 minus f of 4. F of 4, the reason is 5 covers the values from here. Let me try to shed lightly. From 0 up to 5, that is f of 5. Okay. And from 0 up to 4, this is f of 4. So if you want the probability of x is equal to 5, it is f of 5 minus f of 4. And in this case, you are going to subtract 0.8042 minus 0.6296. What you get will be the answer. And the answer is, so probability of x is equal to 5 is 0.1746. Next, we look at probability of x greater or equal to 4. Probability of x greater or equal to 4. Let's look at that. So the probability of x greater or equal to 4. Okay. How do we go about this? It is simple. Okay. You have to understand what you are doing. Look at f of 12, the last value, minus, from x less 4 plus x greater or equal to 4, the probability must be 1 because you have summed all the x values. So probability of x greater or equal to 4 is the same thing as getting the sum of all probabilities minus the cumulative from 0 up to 3. So this is minus f of 3. Okay, what are we getting? 1 minus, this is 0.4114. Okay, giving the answer as, so next we are looking for probability of 3 less x less or equal to 7 in discrete unknown variables. The x value, which is more than 3, the probability of 4 is less or equal to x less or equal to 7. But how do we go about this? Okay, we know that the f of 7 will sum from 0 up to 7. Okay, and the f of 3 sums from 0 up to 3. So we want 4 to be part of our probability. So this is minus f of 3. Okay, if you subtract f of 4, it will not give you the exact value because f of 4 is from 0 to 4. Then you'll be summing from 5 to 7. So if you want from 4 up to 7, then it is f of 7, which is 0 to 7 minus 0 to 3. There you cover the values 4 up to 7. So substituting in gives us f of 7 is 0.96, 0.9679 minus f of 3 is 0.4114. So when you subtract, you end up with as the answer. So part D, we have the answer 0.5565. Then E, we have they want you to find probability of 1 less or equal to x less than 9. Okay, we want x values from 1 up to but not including 9. Okay, so this is gonna be f of 8 because we shall sum from 1 up to 8 minus f of 0. Okay, so f of 8 minus f of 0 is 0.9900 minus 0.0115. So when you subtract here, you'll end up with the answer is, do the subtraction. Let me also do it from my head, but it is a bit hard, so it takes some time. So the answer is 0.9785. So that is the other good thing with the cumulative. This part I've been doing is going to be so useful when we go to the normal distribution. So learn how to manipulate probabilities. Now, there's something I want to tell you about the median. Median of a discrete, okay, random variable. it is so important you get to know about the median. If you have the cumulative distribution function, you can always tell which value is the median. The median is that value of x with a probability equal to or more than 0.5. Okay. Now, if x1 is the median, then, okay, the probability of x less x1, which is we can write as f of x1, okay, must be greater or equal to 0.5. Hello? Also, the other thing you have to know about median, this is the first condition. The second condition is that the probability of x more than, okay, or equal to x1, which is the median value, this must be always more than 0.5. Okay, this is it must be greater than 0.5. So when you check our table here and try to check, you look at the x value, the first x value, okay, with a probability that is either equal or more than 0.5. So in the above example, this one I'm just adding in this question. It was not part of what we are supposed to discuss, but I feel I should give it to you, okay? In the above example, okay, the median is 4 because f of 4 is equal to 0.62, okay, 0.6296, and the f of 3 was 0.4, so we can't take a 3 because it is less than 0.5. But f of 4 is the first value, okay, whose cumulative probability is more than 0.5. So we take the median as 4. And if we go ahead and try to look at the probabilities, x greater or equal to 4, okay, using this other part from from 3, or we don't have it, okay, but x greater or equal to 4, that probability is going to be more than 0.5. So you can always get the median if you have the cumulative distribution function. If you don't have the cumulative distribution function, then you have to add the probabilities and see that x value whose cumulative probability will be more than or equal to 0.5. Okay, so that is it. The mod is the value of x, the highest probability. So just look at the value of x, the highest probability, that's going to be the mod of a discrete random variable. So that's what I wanted to highlight for you. Ladies and gentlemen, I feel like giving you one more example, but I think this is enough, okay? This is a lengthy video because I had to put in my real video for people to take a look at me and see who is this brain behind everything. I'm the one. So, ladies and gentlemen, this is the end of our discussion about discrete random variables. Okay, if there are questions, maybe we can hand about discrete and a bit complicated. That's what I will do next. But our next discussion is gonna be a special discrete random variable that we start at the advanced level, and that's what we call the binomial distribution. Okay, we also look at the uniform but not so amplified. So thank you so much, ladies and gentlemen. Let me end my discussion today. See you next time.